Hello guys and welcome to my channel. In this session, I want to talk about decision management process, which is the third technical management process. Let's get started and as always, have a good one. By the end of this video, you will be able to answer all these questions correctly. So pause the video now and try to find out if you're able to answer these questions. Note that I will answer all the questions at the end of this session. The purpose of the decision management process is to provide a structured analytical framework for objectively identifying, characterizing, and evaluating a set of alternatives for a decision at any point in the life cycle and select the most beneficial course of action. This table provides a partial list of decision situations or opportunities that are commonly encountered throughout a system's lifecycle. Decision management is a critical systems engineering activity. Consider the number of decisions involved in identifying a business or mission need, crafting a technology development strategy, defining the stakeholder and system requirements, selecting a system architecture, converging on a detailed design, developing verification and validation plans, determining make or buy decisions, creating production ramp-up plans, crafting maintenance and logistics plans, and selecting disposal approaches. New product developments entail an array of interrelated decisions throughout the system lifecycle. The decision management process transforms a broadly stated decision situation into a recommended course of action and associated implementation plan. The process requires a decision maker with full responsibility, authority, and accountability for the decision, a decision analyst with a suite of decision tools, subject matter experts with performance models, and a representative set of end users and other stakeholders. The decision process is executed within the policy and guidelines established by the system sponsor. A well structured decision process will capture and communicate the impact that different value judgments have on the overall decisions and facilitate the search for alternatives that remain attractive across a wide range of value schemes. Inputs and outputs for the decision management process are listed in this slide. The decision management process includes the following activities: prepare for decisions, develop the decision management strategy or approach for system or project decisions, establish and challenge the decision statement and clarify the decision to be made, determine the analysis, methods, other processes, and tools required to support decision activities. Note that the system analysis process is often applied to perform analysis to provide input for the decisions, provide resources to implement the strategy, analyze the decision information, frame, tailor, and structure each decision, develop objectives and measures, generate creative alternatives, assess alternatives via deterministic analysis, synthesize results, identify uncertainties and conduct probabilistic analysis, assess impact of the uncertainties, improve alternatives, communicate trade-offs, present recommendation and implement action plan. Make and manage decisions. Record the decision with relevant data, models, and supporting documentation, that is, the decision authority, source, and rationale. Describe analysis methods, other processes, and tools actually used to support decision activities. Communicate new directions from the decision. Since there are many decisions across the spectrum of project management, system definition, and lifecycle activities, the decision management process is applied in conjunction with most of the technical management and technical processes. It is important to verify and validate the data and assumptions used in the decision analysis, since the validity of the analysis results depends on the use of valid data and assumptions and the application of appropriate analytic methods. Systems engineering practitioners face many decision situations throughout the lifecycle of a project. They must choose the analytical approach that best fits the frame and structure of each decision problem. For instance, when there are clear, important, and discrete events that stand between the implementation of the alternatives and the eventual consequences, a decision tree is often a well suited analytical approach, especially when the decision structure has only a few decision nodes and chance nodes. As the number of decision nodes and chance nodes grows, the decision tree quickly becomes unwieldy and loses some of its communicative power. Furthermore, decision trees require end node consequences be expressed in terms of a single number. The decision management method most employed by systems engineering practitioners is a multiple objective decision approach, or MODA, in which an objective function is formulated to synthesize an alternative's response across multiple, often competing objectives. The aim is to define, measure, and assess stakeholder value and then synthesize this information to facilitate the decision maker's search for alternatives that represent the best balance with often competing objectives. If time and funding allow, systems engineering practitioners may want to conduct trade studies using several techniques, compare results, and reconcile and differences to ensure findings are robust. The following are a summary of decision management good practices: framing, tailoring, and structuring decisions, capturing a description of the system baseline as well as the concept of operations with some indication of system boundaries and anticipated interfaces helps ensure the understanding of the decision context. This includes such details as the time frame allotted for the decisions, an explicit list of stakeholders, a discussion regarding available resources, and expectations regarding the type of action to be taken as a result of the decision at hand. It may also include decision anticipated in the future. Developing objectives and measures. Defining the decision to be made may require balancing a large number of ambiguous and potentially conflicting stakeholder need statements, engaging in uncomfortable discussions regarding the relative priority of each requirement, and establishing walkaway points and stretch goals. Most important decisions involve multiple objectives, and usually with multiple objective decisions, you cannot have it all. You will have to accept less achievement in terms of some objectives to achieve more on other objectives. But how much less would you accept to achieve how much more? Use the information obtained from the business or mission analysis, stakeholder needs and requirements definition, system requirements definition, system architecture definition, and design definition processes to develop objectives and measures for models that use fundamental objectives, or why, what, where, and when, but not means objectives, or how. For each fundamental objective, a measure must be established so that alternatives that more fully satisfy the objective receive a better score on the measure than those alternatives that satisfy the objective to a lesser degree. These measures, also known as measures of effectiveness or MOEs, key performance parameters or KPPs, measure of performance or MOPs, technical performance measures or TPMS, critical performance measures attributes, criterion, or metrics must be unambiguous, comprehensive, direct, operational, and understandable. Generating creative alternatives. For many trade studies, the alternatives will be systems composed of many interrelated system elements. It is important to establish a meaningful product structure for the system of interest and to apply this product structure consistently throughout the decision analysis. The product structure should be a useful decomposition of the elements of the system of interest that explores the trade space. Each alternative is composed of specific design choices for each element. The ability to communicate that differentiating design features of the alternatives is essential. An alternative to a finite number of alternatives is set-based design or SPD. SPD has been shown to effectively and efficiently explore the trade space. Assessing alternatives via deterministic analysis. The decision team should engage subject matter experts or SMEs by creating models using operational and test data aligned with the defined objectives, measures, and alternatives to assess performance and using structured scoring sheets. Each score sheet contains a summary description of the alternative and the scoring criteria. Ideally, the models and simulations should be integrated with the performance, value, and cost models so a design change impacts all models. Synthesizing results. Using the data summarized in the objective measure consequence table, explore, understand, aggregate the data, and display results in a way that facilitates stakeholder understanding. Identifying uncertainty and conducting probabilistic analysis. It is important to identify potential uncertainties surrounding the assessed score and variables that could impact one or more scores. One example of uncertainty is that system concepts are described as a collection of system element design choices, but knowledge of the system element performance during system design is often incomplete. Subject matter experts can often assess an upper, nominal, and lower bound score by making three separate assessments. 1. Assuming low performance, 2. Assuming moderate performance, and 3. Assuming high performance. Accessing impact of uncertainty. Decision analysis uses many forms of sensitivity analysis, including line diagrams, tornado diagrams, waterfall diagrams, and several uncertainty analyses, including Monte Carlo simulation, decision trees, and influence diagrams. Monte Carlo simulations are used to identify the relative impact of each source of uncertainty on the performance, value, and cost of each alternative. Risks should be identified when significant uncertainty is present. Improving alternatives. One could be tempted to end the decision analysis here, highlight the alternative that has the highest total value, and claim success. Such a premature ending would not be considered good practice. Good practice includes further analysis to mine the data generated for the first set of alternatives to reveal opportunities to modify some system element design choices to identify untapped value and reduce risk. Communicating trade offs. The decision team should identify key observations regarding what stakeholders seem to want and what they may be willing to give up to achieve it. The decision team highlights the design decisions that are least significant and or most influential and provide the best stakeholder value. In addition, the important uncertainties and risks should also be identified. Observations regarding combinatorial effects of various design decisions are also important products of this process step. Finally, competing objectives that are driving the trade offs should be highlighted as well. Presenting recommendations and implementing the action plan. It is helpful to clearly describe the recommendations as an actionable task list to increase the likelihood of the decision analysis leading to some form of action showing tangible value. Decisions should be documented using digital engineering artifacts. Reports that include the analysis, decisions, and rationale are important for historical traceability and future decisions. Question number 1. In which decision management practices the SMEs can often assess an upper, nominal, and lower bound score of performance? A. Accessing impact of uncertainty. B. identifying uncertainty and conducting probabilistic analysis, C. Communicating trade offs, and D. All of the above. Well, the correct answer is B. Question number 2. Which LET is covered in presenting recommendations and implementing the action plan? A. Scalability, B. Traceability, C. Modularity, and D. Reliability. The correct answer is B. Question number 3. MODA is the decision management method most employed by systems engineering practitioners. True or false? Well, the correct choice is true.